Hello, hello, hello everyone. Good evening. Welcome back once again. Sorry, last week not able to continue. So good evening everyone. Jai Hind. Please let me know I'm audible. Sorry, last week not able to continue. So good evening everyone. Jai Hind. Okay, yeah. So I'm audible. So guys, today topic is very important as I'm still working and trying to give you the best knowledge. I am not going very fast. Yes, this is my mistake that we are not live in last week. So today I'm taking care of or I'm going to cover a very important topic that is called a register. But before that, Reg, uh, let's let's discuss what I have discussed in last class. Okay, so in last class I have started basic elements and or I can say the basic language elements used in a Verilog. So if you all remember that we have discussed about the logic value 0, 1, x, z in Verilog. Then we discussed about the size, radix, and numbers, and different types of size, radix, and numbers. Suppose that what happen if size is not matching with the number, or what happen if number is not matching with the size. And if we don't have a size, then what is the default value? And if we don't have the radix, then what is the default value? Okay, so we have gone through in very detail. We have discussed and given some example how to write it and etc. etc. Then we also discussed about the 2s complement of the your number systems. Okay, and we also discussed about the string, escape identifiers, underscore. What is the use of underscore? What is number line, uh, tab lines? Okay, blank space, right? So we discussed many things today. I'm planning to discuss about the reg. Okay, reg is very important. Okay, try to understand today. The topic is actually a backbone of the Verilog, backbone of the Verilog, right? The word is known as reg, reg. Okay, so we'll discuss, but let's start with the data types. What is data types in Verilog, etc. If you are aware of the C and C++, you must be know what is data types. Okay, so let me back to the screen. HDL. Okay, I hope. Okay, data types. Okay, so in last class we discussed till keywords. Okay, shift. Oh, I need to set the display. Okay, got it. Okay, so data types as okay. One more thing, I have created a PPT because I don't want to write it and explain it. Uh, I will go through the line by line PPT so that it should give a better clarity. Okay, because we are not doing right now any programming, and we are not doing right now any digital circuit. Okay, so in digital circuit, if we are implementing something digital logic, then I have to directly work on the system. If I am working on coding, then I have to directly work on the tool. Okay, so why I am sharing this PPT so that you should have better clarity and you also go through the line by line. Right. And the book I recommend for this is Samir Palitkar or whatever the book is available at your end in your library or online, offline. So please go through the book. All concepts is available in a book. Okay. So what is data types? predefined Verilog data types. Okay, so it is divided into the two nets and registers. That is the connectivity and storage. Okay, I will share you the definition for this also. Okay, so this is a small table which I have mentioned here. Just for your information, uh, there are many nets or connectivity which we are using in Verilog, like try-end, WN, WOR, try-end, try-OR, supply 0, supply 1, and try 0, try 1, try reg. Basically, these types of Verilog is basically, sorry, this type of wire basically we use in an advanced Verilog. Okay, that we call a something like a CMOS modeling. Okay, so in that case, we required this type of modeling. Sorry, this type of next connectivity. Okay, so today we'll discuss only wire because wire is very famous in Verilog, and we will go in very much detail about the nets and registers, especially reg. Okay, so now let's come to the definition. Now, what is data types in Verilog? In Verilog, data types are used to represent signals. Signals, okay. In Verilog, data types are used to represent signal. Here, signal means your connections, your how the current is flowing or how the information is flowing. Okay. Again, in Verilog, data types means, or I can say data types are used to represent the signals. Okay, the signal means the information which is flowing from one end to the another end, and store value in digital circuit. Right. So here the store value means what is the value is stored on identifier which you have used or which you have defined on output side or input side. Okay, so this is very important to understand that what is data types. So data types are used to represent the signals and store values. Okay, so try to understand when we are using the signals or wire or when we are using the reg as a storage element. This is important to understand. Okay, so mainly Verilog data types are divided into two: net data types and variable data types. Okay, so if someone is asking the question, interview question is like if you are saying, sir, I am okay with Verilog or I am familiar with Verilog, then a question will be like, what is data types? So you have to reply in such a way, sir. Thank you for asking the question. Data types are are basically provide the information about signal and storage and or about the storage elements. Okay, data types are which provide or which represent the signals or storage value of my elements. Okay. Okay, so there are two types. One is net and one is variable data types. Right. So we will discuss one by one net and variable. Okay. So one small description I have created for you. So regarding the nets, a nets represent the interconnection between hardware element. As I mentioned, this is your nets. Okay, this is your input, this is your output. If you remember in our gate level modeling, I have used a keyword wire. Okay, a wire which is connecting between input and output. Okay, so we are already used one of the data types. We are already used one of the data types that is called a nets. Okay, so inside the nets we have there are many connecting data types. There are many connectivity, or I can say there are many types of wire is available inside the nets. Okay, for example, wire, try-end, try-OR, WN, WOR, try-reg 0, try-reg 1, etc. etc. So one of the net is wire. Okay, so wire. The value of net variable is determined throughout the simulation by output of the component is connected called drivers. Okay, so this line basically showing that the value of net. Okay, so basically here what this line means that the information is basically flowing from input to output, that is through wire, that is through this nets. Okay, if no driver is connected to a net, the net default value is Z. For example, if we are not forcing any value, okay, if we are not forcing any value here, where is my ha? If we are not forcing any value, okay, if we are not forcing any value like 0 or 1, okay, then the what is the default value? If we are not forcing any value 0 or 1, what is default value is Z. Okay, so what is net? Net is a connection between the input and output. Okay, and the default value of the net is Z. If we are not forcing any value, okay, that you have to maintain this. The most commonly used type of net is wire. As I mentioned, wire. Okay, if you remember in our first class in gate level modeling, we have called wire. Okay, and if you remember in our schematic class, there is a many number of lines which are connecting from one gate from one output to the another input. Okay, so you can see here the very basic code is that module my circuit output F input A B C D E wire N1 and wire M1X0. Okay, so these are the basically wire. Okay, so which you have defined. So where you have to define? You have to define inside the module. Okay, see, I have mentioned here some other types of nets will be discussed later in advanced Verilog concept. Any undeclared nets default to type wire. Okay, now let's move to the next PPT. Okay, uh, some basic information about again wire or net data types. You can go through it or let me explain one by one. Net types represent a physical connection between hardware elements. Okay, as I mentioned, this is just a summary of net data types. Okay, so basically, net is represent a physical connection between the hardware elements. Okay, so if you have a two hardware elements. So basically, this is basically the net is basically representing the connection between the these two hardware. Okay, the most commonly used, as I mentioned, wire. Okay, so used to connect gates or modules. As I mentioned that used to connect gates or modules. If you are two modules like half adder. So basically, you are connecting the two modules. Okay, so that is why we have defined the wire. Okay, or it is used to connect two hardware. Okay, two gates like this. Okay, this is also a net or we assign as a wire, and this is also a net we assign as a wire. Okay, cannot store a value. Okay, so basically it is not store a value. That means basically there are few data types which store a value and which gives a proper information in a Verilog module. Okay, but here net doesn't contain any or I can say it does not or it don't have a concept to store the value because it is just a simple interconnections, okay, between the two gates or two modules, right? So one more important thing which we are going to learn, that is called a continuous assignment statement. So basically a continuous assignment statement we are going to learn in data flow modeling. Okay, in data flow modeling. So I will discuss more about continuous assignment statement in data flow modeling. Okay, so here basically they have I have just mentioned, just want to give the information about the coming agenda. Okay, so what you have to remember that wire is just a physical connection between the two gates, two modules, and it doesn't contain any information. Okay, and the default value of the wire is Z. So these are the basic interview questions or objective questions. Okay, so wire is also heavily used in data flow modeling. Okay, and with the help of the keyword assign. Okay, so that is a different thing. I'm not going to discuss today. Okay, so next, just example of one of the example of the wire. Okay, module, uh, a simple wire example. I have defined keyword wire here. Reg I will discuss later on. Okay, reg I will discuss later on. Don't be confused here. Okay, so how we will define the wire, that is important. So we will use the keyword wire and we will define or we will write or we will assign any variable, any user defined name. So y is basically a user defined. Okay, so see again. Okay, I have used again a keyword assign. Okay, so basically, uh, if you want to assign the output to the input, okay, let me tell you what is continuous assignment statement. So, continuous assignment statement is basically you have a RHS and LHS. Okay, so something you are assigning from out input to output. Okay, something which you are assigning from output to input, which is in continuous mode. Okay, which is in continuous mode, that is called your continuous assignment statement. Okay, so basically here the keyword assign is basically reflect the objective of continuous assignment statement. That is, you are assigning the calculation, you are assigning the sum operation, you are assigning the sum operation to the output. So that is the purpose of continuous assignment statement. So basically you are performing some operation on right hand side and you are assigning those operation to the left hand side. Okay. So this is uh, known as a continuous assignment statement. So basically here the objective of keeping assign is here that you can assign some values, you can assign the output or you can assign some values to y if you are calling with the help of assign. Okay, so uh, for example, you have defined module, then module name wire, you have taken one reg a and b. Okay, so the concept of reg is, if you remember that I was mentioning, I have mentioned in the test bench that reg is basically stores some value. So we will discuss today in detail. So here we are using reg a and b, and we have defined and we have assigned the value of a and b under the initial. Okay, so under the initial we have assigned a is equal to 1, b is equal to 0, right? And then we have performed one operation. This is one operation of ANDing. So the ANDing operation is a and b. So the value of a is 1, b is 0. So what is the output of y? Output of y is 0 because there is a AND operation. So the priority is goes to 0. Priority goes to 0. Okay, so this is just I am just with the help of some program or some virtual program, I want to give you the information that how, where basically assign is called, where basically initial is called, where basically reg is called. So to providing you the this type of example basically help you to understand, to collect the information that when and where you are calling the your keywords. Okay, so see, if you in starting sorry in upcoming classes you will come to know that you are not going to assign the keyword, you are not going to use the keyword assign inside the initial and always, there is some because there is some for particular purpose. Okay, so we are not going to use the keyword assign inside the initial and always, we will discuss later on. Okay, so this is a simple example of wire. Okay, with the help of keyword assign. Okay, next. Okay, so summary is very clear. There are, what is data types? Data types which are used to represent, data types are used to represent the signals and signal and store values in digital circuit. Okay, signals and store value in the digital circuits. Okay, one example, just for example. So basically, So you are getting some output here, okay, and you are forcing some value here, right? ABC. Okay, so the information which is floating here, okay, between the two gates or two modules is called a net data types. Net data types, okay, which is we use as a keyword wire in small. And if we are getting something at output side or the value is stored somewhere here, okay, value is stored somewhere here, okay, value is stored somewhere here, okay. So for this purpose also we have some data types, okay. For this purpose also we have some data types. I'm just giving the basic details, okay. So here we will use the keyword reg, okay, just for information, okay. So represent a signal, so this is basically representing the signal, okay, signal. And this is basically representing the store, storage the store the value in digital circuit, okay. So for this we have two different types of data types. One is called a nets, connect connectivity. One is called a storage, okay. So here ओके, ये मैंने एक्सप्लेन किया हुआ है, ओके. सो नेट मीन्स समथिंग विच इज between the two hardware, okay. And storage something which we have to store and use it for some other purpose, okay. So for that we have a different set of data types, okay, that is called reg, integer, real time, and etc. Okay, okay. Now, now come to the second type of data type, that is called a variable. Okay, generally we call all these. Okay, okay, all these we call as a variable. What is variable? Basically, variable which store the value and then change it after some time. Okay, whenever the new value came, the old value is replaced by the new value. Okay, so that is actually a meaning of variable. Okay, variable data types. Okay, so in some book it is written as variable data types. In some book it is written as a register data types. Okay, so don't be get confused. Okay, so very simple. I have clearly mentioned here net and variable. Okay, because inside the variable we have four types of data types, okay, which are: one is reg, one is integer, one is real, one is real time. So basically these four data types basically used inside the Verilog in behavior modeling to perform the some operations, okay, like some mathematical operations or some sequential operations, okay, some real time operations, some floating operations, right? So don't be get confused. If you know that key, if you are aware about key, instead of variable you are using the keyword register, no, okay. So this I am using the separate word register separately, okay, not here, okay. See, I am using the register word here, okay, not here, okay. So inside the variable data types, which basically used for the storage purpose. Okay, so we have a four or five. One is reg, store a logic value; integer, support for computations; time, store a time as a 64-bit unsigned quantity; real, store values like delay as a real numbers in point. Okay, and real time, store time values as a real number. So basically, as a designer, you have to think in such a way that which data types give you the real type hardware. Okay, which data types will give you the real time hardware. Okay, hardware means synthesis. Okay, इनमें से कौन से डेटा टाइप्स हैं जो आपको हार्डवेयर प्रोवाइड करेंगे. Okay, only 2, 3, 4, 5. So we will see later on. We will perform and we will analyze that which data types will give us the hardware. Okay. Now come to the theoretical part. Okay, so this is going to be a little bit lengthy session because I have tried to give you all the information with respect to the data, with respect to the reg data types. Okay, so variable or register data types. I have mentioned here also. So the variable or register types can store a value. As I mentioned, they are basically storing the value. Okay, so variable, as I mentioned previously, that variable basically it is a interface between the between the two modules. Okay, interface between the two modules which store the value and use after some time. Okay, or new value will come, new value will be stay there, and then it perform the operation, and then again new value will come and perform the operation. Okay, so that is the purpose of variables. Okay, so one of the variable is known as register. So what register do basically here? Okay, or what basically the variable do here? It stores data value and use inside the initial and always. Okay, team members maybe not aware about the initial and always. Okay, so this initial and always are basically used for use inside the behavior modeling. Okay, so these two initial and always are basically the two different blocks used in a behavior modeling. So as I mentioned, there are three modeling. Okay, one is gate level modeling, one is data flow modeling, and one is behavior modeling. Okay, so behavior modeling, 99% people are using the behavior modeling to design the circuit. So inside the behavior modeling, there are two blocks which is called initial and always. We will discuss this in behavior modeling. Just for information, I am mentioning here. Okay, so what is initial? Something which start at 0 nanosecond and terminate at 1 nanosecond. So, so if anything, we are assigning inside the initial. Okay, the initial means we have to assign some value just at the starting point, just as the starting point of my logic or of my programming. So that we have to define inside the initial. Okay, what is always? If something we are repeating, if we are making some logic which is repeating after a fixed interval of time. So for that purpose, we have to use the keyword always. Okay. So now let's go through the statement. So register are variables that store values. It is an abstraction of a hardware storage element, but it's not need correspond directly to the physical storage element in a circuit. Register retain value until another value is placed on them. Unlike a net, register does not need a driver. A register object may be assigned a value within a procedural statement, a user sequential primitive task or function. Okay, so now in this paragraph, basically it is giving you the message that register is basically one of the data types, okay, which comes under the variable. Okay, it is one of the data types which comes under the variable, okay, which is known for the storage. Okay, so basically the reg is not giving the message that it is actually adding a real-time hardware. Okay, it is not actually giving me the message that it is a real-time hardware. For example, it is not like that it is a D flip-flop. Okay, it is not representing a physical storage element. Okay, that line basically this line is giving the message that but it does not correspond directly to the physical storage element in a circuit. Okay, so this register is basically used in behavior modeling. Okay, in behavior modeling, that is third type of modeling where basically we have to store the values and use for some other purpose. Okay, so that is actually the purpose of the storage element. Okay, so this storage element is not going to use in a combinational logic. Okay, it's not going to use in a data flow modeling or in a Gate load modeling. Okay, very simple. It is written here. Okay, see here. A register object may be assigned a value within a procedure statement. Okay, so this line is very important. As I mentioned, that there is a continuous assignment statement. Okay, continuous assignment statement. So basically, these come under the data flow. Okay, similarly, similarly the procedure. Okay, we will discuss जब इसका टाइम आएगा तो प्रोसीजर असाइनमेंट स्टेटमेंट्स कम्स अंडर द बिहेवियर मॉडलिंग ओके सो बिहेवियर मॉडलिंग के अंदर बेसिकली दो स्टेटमेंट्स आते हैं वन स्टेटमेंट इज योर ब्लॉकिंग स्टेटमेंट वन स्टेटमेंट इज योर नॉन ब्लॉकिंग स्टेटमेंट ओके तो उन दोनों के साथ कैसे हम लोग रेच को यूज कर सकते हैं और इनिशियल एंड ऑलवेज ब्लॉक के अंदर रेच को कैसे यूज कर सकते हैं वो बेसिकली यहाँ पर मेंशन किया है राइट तो ये देखो सीक्वेंशियल प्रिमिटिव टास्क एंड फंक्शन सो दे आर बेसिकली वेरी हाई एंड और एडवांस सिंटेक्स ऑफ द वेरीलॉग ओके so what is variable data type basically the store the value and which is used inside the initial and always block with the help of the blocking and non-blocking statements okay again a small theory again, the reg kind of register data type is the most commonly used. A reg data types models that feature of the hardware that allow a logic value to be stored in a flip-flop or a latch. A reg object can may never be the output of primitive gates or the target of the continuous assignment statement. Okay, so let me explain you. It is very simple here. Basically, in Verilog, basically in Verilog, basically in Verilog, you are using a variable reg. You are using the variable reg for two purpose. For two purpose. One, if one is to store the value. Okay, one is store the value inside the initial. Okay, that is you are assigning some value. Store the value or you are assigning some values. For example, initial. Okay, A is equal to 1 tick B0 and B is equal to 1 tick B1. Okay, so this A and B, you have to assign with the keyword reg A and B. Okay, so basically see here you are storing the value 0 and 1 okay inside your program. So you have to assign this A and B as a reg. Okay, this is the one purpose of this statement. And second, that you are whenever you are making such a logic which represents some hardware, for example, D flip flop, T flip flop, JK flip flop, counter, shift registers. Okay, any type of sequential logic you are making. Okay, so you are basically as the output, the all the sequential output. Basically, you have to assign as a keyword reg also. Okay, so for example, output q. Okay, the same, the same you have to assign with the keyword reg also. Why? Because this q is basically storing the value, and this q can be also used as the input as well as the output in out. Okay, so that is why this output q is basically assigned as a reg. Okay, so the purpose of reg is very simple: to store the value in my logic and to use that value as a input also. Okay, it is assigned as the output, and I want to use that value. I want to use that value, okay, as an output also. Then we have to assign that keyword और दैट आउटपुट विद द हेल्प ऑफ कीवर्ड रेज. ओके, बहुत सिंपल है. मुझे अपने आउटपुट को अगर एज अ इनपुट की तरह आगे जाकर यूज करना है, अभी तो वो आउटपुट दिखा रहा हूं, लेकिन अगर आगे जाकर तो उसको एज अ इनपुट की तरह यूज करना है, तो उस वैल्यू को स्टोर कर कर फिर आगे जाकर उसको असाइन करना है, तो उसके लिए भी हम रेज कीवर्ड यूज करते हैं. ठीक है, धीरे धीरे पता चलेगा आपको कि वेरिलॉग के अंदर basically when you write the program and when you will get the error, okay, then only you can say that you are learning. Okay, so whatever I am discussing here, this is all just a theoretical concept. So basically you have to implement all these theoretical concepts, okay, in your programming, right? So the reg kind of register data type is the one most commonly used. Okay, कहाँ पे यूज होता है? Commonly used in बिहेवियर मॉडलिंग. ओके, बिहेवियर मॉडलिंग में कहाँ यूज होता है? इनसाइड द इनिशियल एंड ऑलवेज. इनिशियल एंड ऑलवेज क्या है? दो ब्लॉक्स हैं. इनिशियल के अंदर क्या होता है? जीरो से स्टार्ट होता है, वन पे टर्मिनेट होता है. ऑलवेज के अंदर क्या होता है? अगर हमें कोई फीडबैक लॉजिक बनाना है तो ऑलवेज यूज करते हैं. उसके अंदर दो स्टेटमेंट होते हैं, ब्लॉकिंग एंड नॉन ब्लॉकिंग. उन दो स्टेटमेंट के साथ बेसिकली रेज का यूज होता है. ठीक है, अब ब्लॉकिंग के अंदर हम लोग कॉम्बिनेशन लॉजिक भी बनाते हैं और सीक्वेंशियल लॉजिक भी बनाते हैं. ओके, सो द मेन पर्पस ऑफ यूजिंग द रेज इन अ सीक्वेंशियल लॉजिक. ओके, so a reg data types models the feature of the hardware that allows a logic value to be stored in a flip flop or a latch. ठीक है, so basically इस लाइन का ये मतलब है कि reg as a variable data types give you the hardware of some flip flop when you are using with the help of some passage clock or negate clock. Okay, so basically ये ये अपने आप में कोई एक स्टोरेज एलिमेंट नहीं है. ओके, अदर देन फ्लिप फ्लॉप. ऐसा नहीं है कि ये कोई स्टोरेज एलिमेंट है, ठीक, अदर देन फ्लिप फ्लॉप. बट एक्चुअली ये रिप्रेजेंट क्या करता है सिंथेसिस में, जब आप इसको पॉसेज और नेगेज के साथ यूज करते हो किसी भी आउटपुट को, तो वो एज अ फ्लिप फ्लॉप बताता है. ओके, हार्डवेयर में. तो ये इस लाइन का मतलब है. अ रेज ऑब्जेक्ट में नेवर बी द आउटपुट ऑफ प्रिमिटिव गेट्स. A reg object may never be the output of the primitive gift or the target of the continuous assignment. The meaning of this line is that a reg cannot be used inside the continuous assignment statement. Okay, the reg cannot be used as a continuous, cannot be used in a data flow modeling. Okay, cannot be used in a data flow modeling. Okay, so the line of the line which basically represent that the reg is not be used inside the continuous assignment statement because it how I explain, because it doesn't what is basically in continuous that data is not stored. Okay, data is keep changing. Okay, but in a procedural assignment statement, the data is basically used to store the value and to design something which where basically you are using that particular value to take the output of some other value. Okay, the default value for the reg is x. Very important, this is an interview question. Okay, so default value of wire is z. Okay, the default value of wire is x. X when there is no driver, when there is no input output is assigned, or I can say when there is no input value is assigned, the default value is x. Okay, why? Because it is x is unknown, and you know that key basically the reg is used at the output side. Okay, mainly the reg is used at the output side, right? Reg generally कहाँ पे यूज होता है? आउटपुट साइड पे यूज होता है. ओके, सो एट आउटपुट साइड इफ initially there is no value is connected, like no 0 or 1 is connected. Okay, then in that case the output is unknown. That is why it is not Z. So basically, the output is X unknown because the initial site, the input site पे आपका floating state है, impedance state है. Okay, it can be zero, it can be one. Basically, you are going to force the value zero or one. Okay, so ये बहुत बेसिक चीजें हैं जो आपको समझना पड़ेगा. Okay, so the simple example है module reg A C initial begin. Okay, so simple example of reg. The syntax of calling reg is that with the help of keyword reg, okay, you are assigning the input or any variable name. ठीक है, variable name that is your basically your user defined a, and I have given a value of a to 1. Okay, then what is the my output is a is equal to 1. Okay, a simple. So with this example, I want to give you the message that how the basically a reg is called. How the basically the reg is called. Okay, so reg is called here by keyword reg, and then you have a variable name. And just one example is that I'm assigning the value of a to 1, and then I'm closing it end module. Okay, begin basically begin and then end module. Okay, so here basically you have a keyword and also. Okay, I there is a syntax error. Okay, so you have a, so anything which you are starting with begin, you have to close it also. Okay, so this is called end module. Then output is equal to 1. Okay, now why we use reg? Now a very important question. Why we use reg? Reg is used when values need to be assigned inside initial and always. Okay, so again, okay, at the last we have to use the behavior modeling. Okay, 99.99%, or I can say 101%, all designers are using the behavior modeling. Okay, so along with behavior modeling, gate layer modeling and data flow modeling also comes in the picture, but there are some rules. Okay, but there are some rules. The rule is that the continuous assignment statement cannot be called inside the behavior modeling. That is the always or initial. This is the one rule. Okay, just sharing for information. Okay, this is just a one rule. Okay, so why we use reg? Values need to be assigned inside the initial and always. If we have to assign some value in the starting of my code, okay, अगर मुझे अपने लॉजिक अपना मुझे ऐसा एक लॉजिक बनाना है जो मेरे पहले से दिए हुए इनपुट पर काम करे, ठीक है, तो उसको हम किस में डिफाइन करेंगे? क्वेश्चन ये है कि मुझे वैल्यू पहले से असाइन करनी है, 0 या 1. मुझे फोर्स नहीं करना है. समझे आप मेरी बात? मुझे फोर्स नहीं करना है, मुझे असाइन करना है. अगर मुझे असाइन करना है तो मैं टेस्ट बेंच बनाऊं या फिर मैं प्रॉपर कोड लिखूं. तो उस चीज को इंप्लीमेंट करने के लिए, ओके, हमको उस पर्टिकुलर वेरिएबल नेम को, उस पर्टिकुलर यूजर डिफाइंड वेरिएबल नेम को हमें असाइन करना पड़ेगा इनिशियल के अंदर. ठीक है, मैंने अभी थोड़ी देर पहले एग्जांपल दिखाया था. ठीक है, तो फिर से बता देता हूं. इनिशियल, ओके, अगर मुझे reg A and B, okay, so initial begin A is equal to 1 tick B1 and B is equal to 1 tick B0. ओके, सो मुझे इन दो वैल्यू को यूज करना है आगे जाकर, राइट? तो मुझे कहीं तो ये वैल्यू असाइन करना पड़ेगा ना. तो ये वैल्यू कब असाइन होगा? इसको जब मैं ए और बी को एज अ वेरिएबल डिफाइन करूंगा, नॉट एज अ आउटपुट, एज अ वेरिएबल डिफाइन करूंगा टू स्टोर दिस 1 and 0. ओके, सो दिस इनिशियल comes under the behavior modeling. Okay, and same always. ओके, सो अगर मैंने इस वैल्यू को डिफाइन कर दिया, अब मुझे इस वैल्यू को यूज करना है, कोई लॉजिक बनाना है। प्लीज ट्राई टू अंडरस्टैंड, इनिशियल के अंदर हम बहुत सारे लॉजिक नहीं बना सकते हैं। ओके, हम बहुत सारे मतलब बहुत सारे एडवांस सिंटेक्स हम नहीं यूज कर सकते हैं इनिशियल के अंदर। हम वो सारे सिंटेक्स यूज करते हैं ऑलवेज के अंदर। तो अब मुझे इन वैल्यू को ऑलवेज, इन वैल्यू को यूज करके मुझे कोई लॉजिक बनाना है। ठीक है, इन वैल्यू को यूज करके मुझे ऑलवेज के अंदर ही यूज कर सकते हैं। ठीक है, ऑलवेज एट द रेट, ठीक है, कुछ पॉजिटिव एज या नेगेटिव एज के साथ मुझे इसको कुछ लॉजिक बनाना है, राइट। तो अब ये जो मेरा ए एंड बी है, राइट, कि मैंने कोई आउटपुट लिया, आउटपुट वन इक्वल टू ए एंड बी। ठीक है, तो मैंने इस तरह से असाइन कर दिया, आउटपुट वन को ए एंड बी मैंने असाइन कर दिया। तो आई हैव परफॉर्म सम लॉजिक। सो बेसिकली ए और बी की वैल्यू कहां से मिली, इससे मिली, और उसने आउटपुट दे दिया। सो वेयर वी यूज द रेज, रेज वी विल यूज द रेज इनसाइड द इनिशियल एंड ऑलवेज। ओके, कहने को इन जस्ट 30 सेकेंड आई कैन फिनिश द रेज। ठीक है, बट आई नो कि इफ यू डोंट अंडरस्टैंड द रेज, you don't understand the Verilog. Okay, so that is why I am trying to give you the more information about the reg. So just hold and just watch it. Okay, a signal must hold a, कब यूज कर सकते हैं, जब सिग्नल, जब उस पर्टिकुलर वेरिएबल नेम को हमें यूज करना है किसी वैल्यू को स्टोर करने में या होल्ड करने के लिए। ओके, सो व्हाट इज रिक्वायर्ड, बिहेवियर मॉडलिंग इज रिक्वायर्ड। So ultimately, in one line, reg is a part of the behavior modeling. Reg is used only in behavior modeling or in test bench to store the value or to hold the value. Okay, very simple. To store the value or to hold the value. कहाँ पे यूज होता है, इनिशियल एंड ऑलवेज के अंदर। ओके, किसके साथ यूज होता है, ब्लॉकिंग एंड नॉन ब्लॉकिंग स्टेटमेंट के अंदर। स्टिल आई हैव नॉट tell you what is blocking and non-blocking. Okay, that is very important concept that we will learn when we will start the behavior modeling. Okay, I hope आप लोगों को समझ में आ रहा होगा, right? So next slides. Okay, just a example, very simple examples मैंने आप लोगों के लिए लिखा है। One example, a single bit reg. If you are assigning the value of a in single bit, you have to define like this. If you can also assign the value of reg in multiple bit. Okay, that is called vector. Okay, so I'm introducing the vector just for information. Vector. Okay, what is vector? When you are assigning the multiple values on a single line. Okay, on a single line. If you remember, in our digital hardware design, when I am designing the full adder, 8-bit full adder, so basically I have taken one line, one simple line, and I have given 8 different values. Okay, so that is called a multiple bit on a single line. That is in terms of hardware design. But in terms of Verilog or any HDL, we will call this as the vector. So vector is basically divided into two, MSB and LSB. Okay, so this is your MSB and this is your LSB. So आप जिधर से भी start करोगे 7 0, that means 7 is to 0. That means the data type 7 6 5 4 3 2 1. So your MSB is always start with the 7. Similarly, if you can also write 0 to 7. So in that case, your data types 0, 1, 2, 3, 4, 5, 6, 7. In that case, your data types start with a 0. Okay, so this is a one simple application of calling the reg as a vector. Okay, here reg calling a vector. Sorry, here reg I'm calling as a single bit. Here I'm calling reg as a multiple bit. Okay, one more thing. Okay, see, reg can also store the 4 different values. As I mentioned, that depend on the operations, the type of logic I am performing. Okay, so the type of logic I'm performing basically and according to that operation or according to that logic, basically your output is stored to the reg. So there are four: 0, 1, xz. So logic low, logic high, unknown, and high impedance. Okay, this is the one example, simple example. This is a one simple example. Don't be get confused that why I'm using the z here. Basically, here I'm assigning the value, but the by default value of y of reg is always x. Please remember this. Okay. So here I'm just giving you the example that how you are basically assigning the values to the reg. Okay. So simple module reg abcd initial begin a is equal to 0, b is equal to 1, c is equal to x, and d is equal to z. Okay, so always initial start with begin and end with keyword end, then end module. Now this is your output. Okay, so this is how basically reg can store the value. Okay, next. Okay, as I mentioned two, three times about the blocking and non-blocking. Okay, about blocking and non-blocking, right? So blocking, non-blocking are the two procedure statements basically used in a behavior modeling. Okay, very important concept. Okay, but now just for your information, here blocking, just for information, assignment to read, assignments are usually done using the blocking. So basically, this is the syntax of blocking, and this is the syntax of non-blocking. Okay, अभी बस आप इतना जान लो, okay, कि what is your blocking statement and what is your non-blocking statement. Okay, so here I have mentioned something called sequentially, and here I have mentioned something in parallel. Okay, so I am not going to discuss about this sequential and parallel because for this I have to create lot of concept to understand the concept of blocking and non-blocking. Okay, but why I have used this slide because अगले स्लाइड में आपको पता चलेगा कि ऑलवेज के अंदर अगर हम किसी रेज को कॉल कर रहे हैं तो वो हम ब्लॉकिंग और नॉन ब्लॉकिंग स्टेटमेंट के साथ कॉल कर रहे हैं ओके इन नेक्स्ट फ्यू स्लाइड्स यू विल कम टू नो दैट कि वी आर कॉलिंग द रेज with the help of blocking and non-blocking statements. Okay, for example, okay, so here, okay, sorry, okay, see, so example of blocking. Okay, so module reg ab initial. So basically, see here, this is your blocking statement. Okay, so this is not a equal statement. So this is a blocking statement. Just for information. Okay, अभी ये वन क्यों आया वो भी अपने आप में डिफरेंट कहानी है ठीक है तो वो हम देखेंगे लेटर ऑन नॉट नाउ ओके क्योंकि उसके लिए हमें फिर आपको समझाना पड़ेगा व्हाट इज ब्लॉकिंग एंड नॉन ब्लॉकिंग ओके सो अभी जस्ट फॉर योर इंफॉर्मेशन just try to understand that reg how we are calling reg and if we are assigning some value of a and b okay right then we are assigning some value with the help of this is actually called blocking statement okay so why what is the output of one that is something a different thing that we will discuss later on okay so basically here it is a and b basically it is swapping the operations okay right now same thing here also example of non-blocking now you can see here the syntax is changed okay syntax is changed okay so here this is all called a non-blocking statement but my objective is just to explain you that if you have call a reg a and b then how basically you are calling with in a initial and always okay so with the help of blocking and non-blocking statements okay See, so that two example based on initial. Now this example is based on always. So module reg AB. So this is basically here. Basically, if I say after this, if I use initial begin A is equal to 1 tick B0 and B is equal to 1 tick B1, and then end, and then this line start. Okay, so basically here with you are using the two variable, that is not as a output. You are using the two variable, but not as a output port. That is a simple storage element. Okay, simple storage element. So you have assigned the value A is equal to 0 and B is equal to 1, and now you are performing the sum operation. Again, why we are using this output as a Y, as a reg, this Y as a reg, because in always, so what is the main fundamental of always? The main fundamental of always is that it's always repeat the value, it's always feedback the value. Okay, so whenever suppose that if this Y is required in some time as an input, okay, then in that case let it have a by default इन असाइन एज अ ऑलवेज. ठीक है, अगर हमने इसको ऑलवेज के अंदर असाइन किया है वाई, बट ये सिंपल ऑपरेशन है, वाई ए एंड बी खत्म हो गया. बट सपोज दैट हम कोई ऐसा लॉजिक बना रहे हैं कि जहां पर इस वाई को हम एज अ इनपुट की तरह यूज करना पड़ गया, तो अगर हम इसको असाइन के अंदर या किसी के साथ यूज करेंगे तो शायद वो चले या ना चले. ओके, बट ऑलवेज के अंदर अगर हमें इस y को यूज करना पड़ा एज अ स्टोर एलिमेंट को स्टोर करके आगे जाकर कोई लॉजिक बनाना पड़ा, इसलिए हम लोग आउटपुट को भी एज अ स्टोरेज या एज अ रेज लेते हैं. दैट इज द मेन मैंडेटरी item, that if you are defining any output in a behavior modeling as a reg, that means that particular value can be used as a input also, as a in-out. Okay, as a in-out. The best example is your flip-flop. The best example is your flip-flop. That is a Q is used as a QB. That is a read used as a write, and QB used as a again as a read write. Okay, so we will discuss. Don't need to worry. Okay, don't get too much confusion. Don't get too much confused here. Okay, so this is a simple example. So this is basically giving the some combinational operation. Okay, combinational logic. Okay, next. So this is a simple operation of your D flip flop. Okay, so here reg q. I have not taken any other element. Okay, I have not taken any other element of or any other variable name. Simple. This q as a defined as the output, and now q as a defined as a reg. क्योंकि अगर आपको फ्लिप फ्लॉप का हार्डवेयर पता है, फ्लिप फ्लॉप स्टार्ट होता है मेमोरी एलिमेंट से, राइट रीड रीड राइट ऑपरेशन से, कि जो आउटपुट है वो इनपुट बन रहा है और जो इनपुट है वो आउटपुट बन रहा है. ठीक है, तो वो लॉजिक वेरीलॉग में परफॉर्म कैसे होती है, ठीक है, उसके लिए ये कीवर्ड रेज यूज होता है. ओके ओके, सो सम मोर एग्जांपल ऑफ इनिशियल. So module vector reg 7 to 0 data. I have assigned some value. Now what is the output? In very simple way. This is my output. Okay. Memory declaration, that is a two-dimensional. Okay. Module memory example. This is basically uh, sorry. This is basically a single dimensional. Okay. So this is a row and column format, and you have assigned the zeroth value, that is a memory 7, memory 6, memory 5, memory 4, memory 3, memory 2, memory 1, memory 0. So you have assigned the zeroth value to AA. So okay, so that is why you have defined this memory as a reg. Okay, so the output of zeroth value is AA. Okay. Now common mistake, as I mentioned. Okay. So you cannot use this Y. You cannot use this Y. Okay. You cannot use this Y if it defined as a wire, because wire don't store the value. Okay. So basically your rel store the value. So if you have assigned something with help of keyword wire, and if you are performing some operation, then this is a wrong, because wire don't store the value. So right example is this. You have to assign with the keyword reg. Okay. Now difference between wire and reg, very important, very important. Okay. So what is wire? Wire which don't store the value. Reg which store the value. Used with the keyword assignment. Yes. Reg, reg variable name cannot be used with the keyword assignment. Use in a always. No, wire cannot be used in a always, because in always you need to be repeat the logic. So repeat करने के लिए आपको previous value पता होनी चाहिए, जो प्रीवियस वैल्यू वायर नहीं होल्ड करता है. ओके, वायर कोई वैल्यू को होल्ड नहीं करता है, सिर्फ रेज होल्ड करता है. इसीलिए ऑलवेज के अंदर हम रेज को कॉल करते हैं. ओके. सो रिप्रेजेंट कनेक्शन, रिप्रेजेंट स्टोरेज एलिमेंट. वेरी सिंपल. ओके. इंपॉर्टेंट फीचर्स ऑफ रेज लाइक store value, yes. Use inside the always, yes. Use inside the initial, yes. Can be a vector, yes. Can store x or z, yes. And hardware type depend on the coding style. मतलब अगर मैं बॉस एज के साथ यूज कर रहा हूँ तो फ्लिप फ्लॉप बना देगा, ठीक है, या मैं इसको वेक्टर के साथ यूज कर रहा हूँ तो वो और कुछ बना देगा. ओके. सो प्लीज सी दीज टू स्लाइड्स आर द इंटरव्यू क्वेश्चंस. ओके. दीज टू स्लाइड्स आर द बेसिक. जब तक आपको बेसिक्स नहीं क्लियर होगा आप वेरिलॉग नहीं सीख पाएंगे. ओके. इंपॉर्टेंट पॉइंट, रेज डज नॉट ऑलवेज मीन अ हार्डवेयर रजिस्टर. मैंने बताया था कि रेज का मतलब ये नहीं है कि आप एक फ्लिप फ्लॉप बना रहे हैं, ठीक है. वो वो फ्लिप फ्लॉप की तरह नहीं काम करेगा. वो डिपेंड करता है कि अगर आप ऑलवेज के साथ उसको असाइन कर रहे हो तो वो फ्लिप फ्लॉप बनाएगा, ठीक है. बट ऑलवेज के अंदर हम रेज को यूज कर सकते हैं विदाउट फ्लिप फ्लॉप, तो वो कुछ कॉम्बिनेशन बना देगा. ओके. तो बच्चे इस पे बहुत कंफ्यूज रहते हैं कि रेज का मतलब होता है फ्लिप फ्लॉप. नो, इट इज नॉट लाइक दैट. रेज मीन डजंट मीन फ्लिप फ्लॉप. If I'm making the combination logic inside the always at the rate, I'm using some sensitive list, some simple inputs A and B, and I'm calling that A and B along with the reg. It's not giving the hardware of flip flop, right? But I'm using the same thing with the help of passage clock and passage clock or negate clock. Then definitely it is give the flip flop. Okay, so ये सब चीजें हम आगे देखेंगे. ठीक है. देखो यहाँ मेंशन है मेरे को, ठीक है. सो समरी, प्रॉपर्टी इज रेज, स्टोर वैल्यू यस, यूज इन प्रोसीजर ब्लॉक यस, सपोर्ट वेक्टर यस, सपोर्ट एक्सजेड यस, यूज इन कॉम्बिनेशन लॉजिक यस, एंड यूज इन sequential logic, yes. Okay, so this is all about reg. I try to give you the best information because if you don't understand the keyword reg, okay, you cannot perform the operation using the Verilog. तो आपको बहुत सारे सिंटेक्स एरर मिलेंगे, बहुत सारे आपको मिल सकता है लॉजिकल एरर भी मिले. ओके. सो प्लीज एवरीवन डोंट टेक दिस Verilog as a theoretical subject. Verilog means completely pure programming hands-on domain. Okay, this is not a theoretical subject, but yes, in last few classes and in upcoming some classes, I have to explain the concept in terms of PPT. ओके. अगर हम एक एक चीज को एग्जीक्यूट करते चलेंगे इन प्रोग्रामिंग में तो बहुत टाइम लग जाएगा. बट यस, अगर आपको ये सब चीजें अभी पता होंगी, राइट, इफ यू नो ऑल दिस थिंग नाउ, कि reg क्या है, wire क्या है, what is reg, what is wire. Then whenever you are using this reg and wire in a programming, definitely it will help you. Okay, no, reg cannot be used as a wire. A wire cannot be defined inside the always. Reg cannot be defined as a assign with the keyword assign. Okay, so these are the basic concept. These are the basic elements of the Verilog. Okay, so please try to understand. Please focus on Verilog, because if you know the Verilog, you can do a lot of things. Okay, so this is all from my side. So thank you everyone. Tomorrow I will take care of integer and then real and then real time and some other data types. Then after that we will move to the data flow modeling. Okay. Thank you very much. Jai Hind.